This video is going to be about adiabatic processes. Just a reminder, an adiabatic process is one where no heat leaves or enters the system, so the energy of the system remains constant. For an adiabatic process, the pressure of the gas times the volume of the gas to the 5/3 power is always constant. This means the initial pressure times the initial volume to the 5/3 power during an adiabatic process will equal the final pressure times the final volume to the 5/3 power. The temperature does change during an adiabatic process, and we'll go through the mathematics to discover the relationship of how the temperature might change with the volume. We'll start out with the gas law, PV equals nRT. I'm going to move things around so that everything equals N times R. Now the number of moles should be constant in this situation, and the gas constant is constant. So I'm going to make nR into a new constant we'll call C1. I'm going to isolate pressure, and I'm going to substitute in the relationship PV to the 5/3 is constant for pressure. I'm going to move all the constants to the left-hand side, and I'm going to move my volume to the right-hand side. And this simplifies to temperature times volume to the 2/3. And this temperature times volume to the 2/3 is equal to the constants. So this value is also constant. So this means the initial temperature of our gas times the initial volume of our gas to the 2/3 is equal to the final temperature of our gas times the final volume of our gas to the 2/3 for an adiabatic process. This means that if a gas expands adiabatically, the temperature of the gas will decrease, and the temperature will increase if it were compressed adiabatically. Now let's look at how adiabatic expansion and compression would look on a PV diagram. During an expansion, the volume will increase, as shown by this green line. So I'm going to write an isothermal first, and during a compression, the volume will decrease, and so I'm going to write a green isothermal to show a decrease in volume isothermally. Now an adiabatic process I'm going to show in red. As we mentioned in the previous video, an adiabatic process has a steeper slope than an isothermal process, but a similar shape. And so an adiabatic expansion will have a steeper slope and be below its isothermal counterpart, and an adiabatic compression will have a steeper slope and appear above the isothermal counterpart.